Good morning, students. And yesterday I have seen some comments regarding the voice clarity and visuality. See, visuality I can correct it today. And the voice clarity, you need to increase the volume of your phone. Then only you can get clear sounds, clear listening mode. So this is up to the end of this month only. Next month onwards, I will take a regular online classes in a Google Meet. End of this month only, I will take the classes through YouTube only. Okay, students. In today's class, we discuss some information about net force. Some information on net force. See, net force is a sum of forces which are acting in all directions. See, so net force is being called the sum of all forces acting on a body. See, usually on a body, the forces, how will it act? This is in what direction? This is what you need to learn. See, I will take some situations. For example, a boy is walking on the road. A boy is walking on the road. He is moving this direction. For example, he is moving in that direction on the road. And now we get that out. What are the forces acting on it? See, we need to think in all the directions. First of all, we need to start up and down. Upward direction and downward direction. See, I already said, in downward direction, as long we are living towards the earth, definitely there will be a gravitational force. So, as he is walking on the road is on the earth, so downwards there is a gravitational force. Downward there is a gravitational force. And next you need to check. The boy is walking on the road. Is there contact between the two or not? So while he walks, definitely there will be a contact. So the contacting rod will try to push the boy upward. This is common thing. Why is when any object is in contact on the base definitely provides an upward force. That upward force I explained yesterday is called a normal force. This is normal force. On this planet, in every action, we can escape any type of force, but it is not possible to escape gravitational force. So every body definitely has a gravitational force downwards. When the body is in contact to the base, definitely the base will provide an upward force on the body, and it is called normal force. Okay, next we need to think how he is able to walk. See, the walking is always based on the grip of his legs on the surface. That means the roughness of the surface and the legs of the boy. You see, when we try to walk on the floor, we are able to walk. On the same floor, when oil is dropped, can we walk? We don't know. So we cannot. Why? Because when oil is dropped, the surface will become smooth. So smoothness will not help us to walk. The roughness will help us to walk. So what kind of force the roughness is going to produce is none other than the frictional force. So here we are able to walk in this direction, means in opposite direction we are going to have frictional force. We are definitely going to have a frictional force in opposite direction. So because of that we are able to walk on that. So like this, in each and every situation we just need to, or we just have an ability to find what kind of forces are acting on it. We need to find those forces in all directions. And see, in perpendicular direction, almost in all the situations, gravitational force is equal to normal force on this earth. If these two are not equal, there is a problem. Why is? If normal force is greater, we cannot stand on the surface. We can fly up because the upward force is greater. If gravitational force is greater, we cannot stand on the surface because of the attraction we go downwards. So gravitational force will pull us down, normal force will push us up, upward pushing force. So as long these two forces are equal, we are stable on the earth's surface. That's the net force. Okay, and horizontally, in this situation there is only frictional force, no problem, but in some situation on the both sides we are going to have the forces. See, the direction of motion, usually the force applied, it is either mechanical force or muscular force. It is being said applied force. So muscular force, mechanical force together called applied force. But in opposite direction of motion, the force whenever acts, it is called frictional force. Frictional force always acts opposite direction of moving body. In the direction of moving body, net force acts. So I will show you in case of bus. So this is the bus. Now, someone have been asked, identify the forces and where are they acting. See, this is the portion of the driver. So what do we expect? In what direction this is all happening? See, before that I already said, first we need to identify anything is upward and downward. See, the object is moving on the earth, so definitely downward there is a force of attraction by the earth, and it is gravitational force. Gravitational force is compulsory. And the bus, with the help of the tires, it is in contact to the earth, so earth will try to push the bus upward. But people, you may get the doubt. Tires are only the parts of the bus in contact to the earth. So where does the normal force act? No doubt, it definitely acts on the both side parts of the tires. On all parts of the tires, only the normal force acts. Not on the remaining part of the bus, because remaining part of the bus is not in contact to the earth. Tires are only the parts which are in contact to the earth. So on the tires, this force will act. So on the tires only normal force act. And the driver is sitting here, means its motion direction is this part. So the bus moving direction, the force is called always applied force. But in opposite direction, to stop the bus, whenever force is required, It is called frictional force. Like this, we can find the forces in all directions. Among these all forces, whose magnitude is larger, that brings the motion. If frictional force magnitude is larger, that stops the object. I said frictional force always stops an object, does not support motion, but the remaining supports the motion. If applied force magnitude is larger, the bus will not stop, will go. If frictional force magnitude is larger, it will not go, it will stay at where it is. That's the ability of frictional force. Okay? And net force, frictional force. These are the forces we have been seeing. Okay, friends? And net force and frictional force. So these are the forces. Okay. And here I need to explain about these diagrams. These are called free body diagrams. For every situation there will be a free body diagram, a rough sketch of a situation, rough sketch of the diagram. That's called a free body diagram. By drawing free body diagram for every situation, we just can find out the forces, and after finding those forces, the sum of the forces whenever we'll take, that sum of forces is called net force. But here we need some sign convention rules. What are those sign convention rules? Listen. To find the net force, we need sign convention rules are these two. Number one, forces acting in same direction are positive. If both forces are acting in same direction, both are positive. But forces acting in opposite direction are negative. If they are acting in opposite direction with each other, one of them is negative, the other remains positive. One direction force is positive, the other direction force is taken negative. So in previous situations we have seen applied force, frictional force, both act opposite in direction. So what do we expect? If applied force is taken positive, the frictional force is taken negative. But in the same bus diagram, we have seen two normal forces are acting upward. So both normal forces are in same direction. So both are positive. So with an example I will explain with a diagram. So this is the diagram, a block. Let us take the force of 50 newtons, and 100 newtons are acting. Observe the arrow marks. Observe the arrow marks carefully. Left side, we have two forces. Both are 50 newtons each. What about their direction of arrow mark? Same direction. So these two are according to the first rule, positive. So to find the net force, what we need to take? Both are positive. But comparing these two, the other side force 100 newtons is in opposite direction. So the force will be negative. Then what we expect, 50 plus 50 is 100 newtons minus 100 newtons is equal to 0 newtons. So the net force will become 0. So what will it explain? So see carefully observe this. Since the net force is calculated 0, what is its effect? If anybody asks, you can say that the object or the block will not move. When net force is 0, it will not move. When net force is positive here, so which forces are positive? Those forces causes the motion. When net force is negative, which force is taken negative? This force causes the motion. For example, suppose the answer we get plus 10 newtons. So plus 10 newtons means what? This 50-50 we have assumed positive forces. So these positive forces will cause the motion and object will move from left side to right side. In case you get minus 10 newtons, so which one we have taken the negative? 100 newtons we have taken the negative. So this one causes the motion and the objects move from the right side to left side. This is the effect of force. Okay, like this various forces you need to observe. Okay, in today's class I can give some diagrams like this. You just try to find out the net forces. Okay, see the diagrams. Ten newtons, 10 newtons, 10 newtons, 10 newtons, 10 newtons. The next diagram, 100 newtons, 50 newtons. Newtons, 50 newtons, 50 newtons, 50 newtons, 100 newtons, 30 newtons. Try to solve these diagrams yourself and you may find you may get an understanding regarding net forces. Okay, in next class we see the effects of force.